Hi, and welcome to session 7. We are moving on to something that isn't graphs today, so I should imagine you're quite pleased to hear that. So we're going to leave the graphs for a little while, going to do something different. Obviously, we've got our recap. I think I mentioned last time that, they are getting big. And they're time consuming. To answer all these questions will take a period of time. So however you kind of set your sessions up, this is going to obviously flow over a few. And also what we're doing today, direct and inverse proportion, these are done in class over 2 lessons, sometimes 3. So again, it's sensible for you to know that and then plan your own timetable. I'm worried that people will think that it's one video you should just do in one session, and it's not really designed like that. It's for you to just work through in however many sittings is right for you. Okay, I'm going to scroll slowly through as normal and do the answers, and then there's a couple I'm going to touch on before we start the main activity. Okay, and there's our answers. So the highlighted ones I have just given answers. If you've got them right, then you're not really going to want to listen to me talking through how to do them, which means you can just forward on to the main activity. If you haven't, though, then obviously the talk through, I hope, will really help you work out where it may be going wrong. So I'm going to just scroll through, just pause, make sure you're marking as best you can, and then I will come back to the others in a sec. Okay, so let's start with question 6. So I've highlighted that because that was new. So you may have found that one tricky. Why have I done it to you? Because it's just really, really important that we keep building on our knowledge. We keep progressing. We don't want to just see questions that we've already seen before. Otherwise, what we do is we learn to answer those questions instead of learning how to use our knowledge to apply to any question we might see. And that's the ultimate goal. We want knowledge of maths to help us work through a problem that we might be facing on a GCSE paper that we've never seen before. That's the ultimate goal, okay? So this is cubed. The opposite is a cube root. And if you knew that, fabulous. This one I've highlighted because I know from experience that whilst it looks quite simple, it can end up really confusing some people. So if that one went wrong, that's the first one I am going to talk through. So let's just get rid of that and create some space. So we were given y equals m over x take 7. Now I've got to undo this, which means I'm going to be taking the minus 7. It's going to be landing as plus 7. So y plus 7 is equal to m over x. Now, x is what I've obviously got to get on its own. I'm not going to be able to do that. I can't just move the m. The m doesn't have anything to move, if that makes sense. If I write m divided by x, I can't grab the m because it doesn't have an operation. So I'm forced to grab the x because it's the only thing with an operation attached to it. So I pick up the divide by x, and when it lands over here, it's obviously going to land as times by x. Oops, trying to rub that out, that didn't work. So what I've now got is y plus 7. So I want all of that to be multiplied by the x. That equals m. But this does mean I can now get it on its own because obviously the times that landed with the x can now be picked up with this bit here, and it can land underneath as y plus 7. So that's how it appeared the way that it appeared. So I'm hoping that has helped if it did go wrong. Let's just go back up to the top and we'll go through them. Okay, so we are, let's make some space. We are looking at a forming and solving equation question. They're giving me some information about the shapes, and then my knowledge about triangles and rectangles, etc., is what is going to be able to complete this task. So it says the area of the triangle is 35.2 centimeters. The height of the rectangle and the triangle are equal, and the length of the rectangle is twice the width. And you've got to work out the perimeter of the rectangle. Okay, so what do I know from that, that blurb, if you like? The area of the triangle is 35.2 centimeters. So my first key word is area. I know that the area of a triangle is base times height divided by 2. And I know that whatever numbers go into base and height, it should give me 35.2 once I'm done. So now I can go to my triangle and I can start putting the information in. So I can see that the base is 8 times by the height. I don't have the height. So I've managed to get a little bit more information, but I'm now really at a point where I have a problem to solve. I've already set the equation up. If I want to know what the height is, I've got to get it on its own. So that's what I will do now. So I'm going to hop, land is times by 2, 8 times the height is now 70.4. I'm now going to pick up the times by 8, and it's going to land as divide by 8, and it gives me the height of 8.8. When I read the next line, it says the height of the rectangle and the triangle are equal. So I now know that this edge here and this edge here, they're exactly the same. I know that the height of the triangle is 8.8. So the height of the rectangle is 8.8. So I'm going to label both those sides. It says the length of the rectangle is twice the width. So I double to get that edge is 17.6 and that is 17.6. And then of course, perimeter is to add all the edges. So that was how you would have got to the answer of 52.8 on that question. Question 9, again, I'm just going to go through it. I just think it's helpful for anyone that got it wrong. So what, I had to work out the value of the smallest angle, okay. What am I looking at? What do I know? Okay, so I am looking at these dashes, which means that the edges are equal. So when I see this as a triangle, I know I'm looking at an isosceles triangle. So these angles here, I know are equal in size. I actually do know this angle. Even though it's not labeled, I know that that angle is the same as that angle because vertically opposite angles are equal. So what I've actually got is, I'm going to draw it huge, so I've got plenty of space to write in it. I know that that angle there is 2x plus 10. I know that is 2x plus 10 because it's an isosceles triangle, and I know that is x. Now I can start to form an equation. I know that the angles in a triangle add up to 180. So I've got 5x plus 20 equaling 180. So now I'm going to go down and get x on its own. So x is equal, when I divide through by the 5, x is equal to 32 degrees. And I know that that is the smallest without having to double check, because obviously that's 2x plus 10. So it's got to be bigger, hasn't it? So that was question 9. And question 10, which I'm going to, because I can't quite fit it all in. Let's just narrow it down and drag it across so that we can just see the whole thing without me being in the way. There we go. Make it a bit bigger now. So we've got a chart, a graph that tells us water flows out of a tank at a constant rate. The graph shows the depth of water in the tank over a period of time. And you had to give an interpretation of the gradient, okay? So again, this is nothing more than your rise and run. I'm just thinking I might have just dropped this now so that it's not working quite so nicely. Let me just get the graph so it's on the squares properly. That's a bit better. So I am running forward. So I have a run of 4 and I'm going down, obviously 2 squares, but I'm using the scales. So I'm at 25 here, I'm at 15 here. So the difference between those two is 10. So I'm doing 10 meters every 4 hours. Now, we always want to try and go to 1 wherever possible so that we're talking about it in its simplest terms. So I just need to divide by 4, top and bottom, which will give me 2.5 meters over 1. And keeping those units really make putting that sentence together a lot easier. It then talks about how many hours will it take to empty the tank. So to empty that completely, okay, we know from the work that we've just previously done that we lose 2.5 in 1 hour. I want to actually lose all 25. I only need to times by 10. So I do the same that side and I've got 10 hours. And I've just used ratios basically, because that's what it is. It's all in proportion. It's going at a constant rate, and that constant situation means I can use ratios in a way to look at that. Okay, so that's the recap, and I hope going through a couple of those answers is helpful. We are going to be looking at direct and inverse proportion, and we are going to be doing that obviously through the entire video. You may want to do direct, take a break, and then do inverse, up to you. So let's have a look at what it actually means. So the amount of miles you can travel is directly proportional to the gallons used. And there I've given some numbers so that we can see what's going on. If it's proportional, they are growing together at the same rate. Going back to kind of ratios, isn't it? So if I've got 50 miles for 1 gallon and I double it to 30, then I double my gallons. The other condition that direct proportion has is a 0-0 situation. And you can see that this would perfectly work here. If I had traveled 0 miles, I would have used 0 gallons. So if you're ever faced with a story and you're trying to work out if it's a ratio styled question, if it's proportionally growing together, think about, does it fit the does it fit the 0-0 test? And that will also help highlight what you're looking at there. Okay, so direct proportion is crossover. There is an equation that goes with direct proportion and extends when you are studying higher. So if you're a higher student, what we're looking at today is going to be really, really important for when you go up to the next level of direct and inverse proportion. But for foundation, it stops at what we're seeing now. And I'm going to show you. I think that's what I'm going to do first. Okay. So the word directly proportional should trigger what we're about to do. So there are key words. There is a symbol that we can use for proportionality. We call it the fishy symbol. So when I read this, the amount of miles, so miles is key. You can travel is directly proportional to gallons. So my equation I'm going to write is going to use the letters M for miles and G for gallons. We really try and use letters to represent the story. And I know that my miles are directly proportional to my gallons. So that's a shorthand way of representing the sentence that we have been given, which is what we tend to do in maths. We're very lazy and we are not going to read and work in sentences when we can read and work in symbols. So that is our direct proportion symbol that we're going to use. That leads us to the equation. So M is going to equal a constant, all right, which I'm going to explain, and G. Every direct proportion question, every single situation that we could think of, if it's directly proportional with the 0, 0 test, then this equation exists every single time, okay? And what we have to do is we have to work out K, okay? And it, again, obviously, I'm going to show you how all of that works. So let's just take from our ratios that we can see, let us take the fact that our miles is 45 when our gallons are 3. And of course, that K is there, it hasn't disappeared. We wouldn't normally write K3, we'd normally write 3K. That's the notation that we are used to seeing. But I'm going to be rearranging this anyway because I want to work out what K is. So I'm going to use a fact about my story to help me find K. So if I want to know what K is, I've got to get it on its own. So I'm going to move the times by 3. It's going to land is divide by 3. And K is going to be equal to 15. So my equation for this story is miles will equal 15 times whatever G is. And that's writing your own equation that's linked to direct proportion. So using all the skills we've been seeing this course. And of course, we can see this. 1 times 15 is 15. 2 times 15 is 30. 3 times 15. So my K is 15. All right. So now we've got a little bit of background knowledge. We are going to try out some bits and pieces and different questions, okay? So this is how it can look. G is directly proportional to H. Write an equation connecting G and T when G equals 6 and H equals 2. So we should be clocking this, and if we can, we would write our little fishy symbol. G is directly proportional to H. Then I need to remember, and you do need to really remember, because there isn't on a formula sheet. This is down to, again, the knowledge that we're trying to build on. So we know it's going to be KH, and then we literally just substitute in the 6 and the 2. So I've got 6 equals K2, rearrange, so divide through by 2, my K is equal to 3. Now I know what K equals, I can rewrite this part of my equation using the value I worked out for K. So G is equal to 3H. And there it is. Now, writing that equation, like I say, is absolutely key for anybody studying higher, because direct proportion goes on into saying things like G is directly proportional to the square of H, or G is directly proportional to the square root of H. And they just bring in powers and roots, and they do other things in the higher course that we don't see in foundation. So we won't see it in this course because it's a crossover grade. But if you're finding the equation a little tricky, and we've only just started, so there's obviously more to see yet. If at any point you think, God, that is a bit hard, but you're a higher student, you've got to really stick with it. If you're a foundation student and you're finding it really, really hard, I've got a little tip for you. I'm not going to share it with you yet because I want you to keep trying with this. But if you are thinking, oh my word, fear not, all right? Because I have got something up my sleeve to help you. Okay, so let's get that out of the way. I would like you this time to use your notes in what we've seen so far and have a go at that question. So hit pause and press play when you're ready. Okay, so P is first. P is directly proportional to T. How are you getting on drawing the symbol? I see some funny looking symbols in class. Okay, mine are pretty funny looking, to be fair. Enough. Okay, so my equation is going to be P equals KT. I'm going to put my numbers in next. I've got 12 for P. I've got 5 for T. I'm going to rearrange through, and I've got 5. So I know that K is equal to 12 over 5. Now, there's always this question, do I leave it as a fraction? Do I take it all the way to a decimal? I think it really depends on the context of the question, because sometimes, really honestly, it's easier to work in fractions than it is in decimals. And other times, it's the other way around. If you've got a calculator, you're probably just going to go to decimals because your calculator is going to do the work for you anyway. So the rewrite on this is P equals 12 over 5T, or you could do the decimal version, which is obviously totally acceptable. They're equivalent to each other. Whichever you do is fine. All right. So that is that. Now, this question has a little bit more going on. I don't want to just sit here telling you how to do everything. I really want you to have a good old think for yourself. So hit pause, go as far as you can. And as soon as you kind of get to a point where you're not sure, or maybe you finished and you just want to check your answer, hit play. Okay, so I know that y is directly proportional to x, giving me the equation y equals kx. When y is 2, x is 5. So I'll divide through, and I've got that my k is equal to 2/5, or I might have written k is equal to 0.4. Fine, whichever you do. Now, the equation is y equals 0.4x, or the fraction. Like I say, it makes no difference, okay? This sort of stuff is on, I mean, I can't promise you, can I? I can't say absolutely you will see this on a calculator paper, but you know what? It generally is. If it's going to be on a non-calculator, they're going to have to be fairly kind with the numbers because you've got to be able to work with them, okay? This sort of stuff is generally on a calculator anyway, okay? So I've got my equation. The last step for this one is when y is 17, what is x? So this is nothing more than a little bit of substitution. If y is 17, then I have 17 living right there. That is going to equal 0.4x. I'm just going to divide through by my 0.4. And that tells me that x is 42.5. Job done. So I've written my own equation and I've used my own equation. Okay. Here's your next question that I'd like you to have a go at. There we go. So press pause, hit play when you're ready. Okay, so we have got, let's take a look. We've got letters M being directly proportional to N. We know, therefore, that the equation is M equals Kn. I have been told that M is 12 when N is 5. So we're going to divide through by the 5 so that I've got K. So K is either 12 over 5 or it is 2 point, oops, hang on a sec. Let's actually put an equal sign in. Dear, it's all going wrong. Equals 2.4. Okay. So we are now going to use that in our equation. So we've got M equals 2.4K. I'm happy with that. So we've got to work out what M is. Sorry, N is when M is 42. So we've got 42 equals, oh, I knew I was doing something wrong. My poor little brain. Right, I'm going to rub this out and redo this. K is equal to 2.4. So I've got M equals 2.4N. There you go. Honestly, it happens to the best of us. It should make you feel very happy that you've just seen that. All right, we are only human at the end of the day, okay? And it's really, maths is so easy to just write something down wrong. Okay, now I'm going to say M is 42. It's going to equal 2.4 times whatever N is. I'm going to divide through by 2.4, and that is going to give me 17.5. So N is 17.5 when M is 42. Hopefully you did that a little smoother than I did. Okay, so here is our next bit of information coming up here. Okay, so Charlie's wage is proportional to the number of hours he works. Charlie earns £132 for 12 hours. Write an equation connecting his wage and his hours worked. And how much will he earn for 39 hours of work? So that one that I've just read out, okay, mentions proportional. It doesn't ask you to write an equation. So, oh, apologies, it does. The one on the other side doesn't. Okay, you're being asked to write an equation. That means you must do it. Okay, and then you'll go on. So it's just a wordy version of what we've already doing. Okay, that's quite rare. For them to actually demand that you write an equation is quite rare. This is generally more likely. So Charlie's wage is proportional to the number of hours he works. Charlie earns 132 for 12 hours. How much will he earn for 39 hours of work? That is much, much more likely. Okay. And this is where actually, if they're not even asking for the equation, do you actually really need to do it? And the answer to that is no, you don't. Because of the proportional condition, you are able to use the magic boxes and labels. And if you've done any other courses with me, you will know that I absolutely love this. Whenever you are stuck, it's such a great go-to. Let's say you were completely stuck on this and you read through and you could at least see, okay, I've got a fact, 132 for 12 hours. I need a fact and I've got it. And I've got 3 pieces of information. That's all I need for boxes and labels. So if you are struggling at all, you can use this system. So I've got pounds and hours. I've got 132 for 12 hours worked. They want me to find out what he's going to earn in 39 hours. I always divide by the number that's trapped. And then I just set everything else up. And I get my answer of £429. That's it. That is actually all you really need to do if they're not asking for an equation. So even if you read that word proportional, yes, it could trigger your equation. And yes, your equation and all the stuff that we've just learned will work, but you can just do it like that and you will get all the marks. All right. You don't get any marks for this because this is kind of a little bit made up. All right. The multiplicative relationship exists. And I've really just come up with boxes and labels as a way of hinging some terminology to a really great way of doing things when you're stuck. Okay. So yeah, there's nothing wrong with this. So if you are thinking, oh my goodness, then keep trying. I'd hate for you to just stop completely. If you're higher, you kind of need to be doing it. But that is a winner. It really is. It's so straightforward. It's going to do it for you. So let's prove that it's going to work, shall we? Although I've done a lot of rubbing off. Okay. But if we just go back up to this one a moment, we did all that work to get to the answer, but actually I've got a connecting pair. So I've got Y and I've got X, 2 and 5. And I know I've got to find X when Y is 17. Divide by the trap number, put the others anywhere that you want to, and you will get the same answer. Okay, so you can pop that in your calculator if you would like to. Okay, and you will get 42.5 coming out of that. So it's a really good go-to. And I do all the time. If there's a connecting pair, really, really important, and that connecting pair has to be side by side as well for this to work. But you put your pair in, you put your third piece of information in the right column. So we had some information about Y, we put it in the Y column, and then you can't go wrong. It's foolproof. So it's really, really good. Okay, I am going to leave you to practice this. So we've got loads, well, not loads, we've got a few questions, don't exaggerate. And obviously work through those. You've got the answers coming, and then we're going to do the inverse. And like I said before, that might be where you probably, if you haven't already, that might be where you'd like to take a break. Okay, so I'll scroll through. I somehow managed to write question 4 twice. That was clever. Okay, there we go. So you can see that I've worked it through both ways. So if you're doing it with the equations, you've got your results, and if you were doing boxes and labels, you've got that as well. And it's quite nice to demonstrate that side by side so you can see how they're both actually coming out with those same answers. Okay, so we're going to look at inverse proportion. Inverse proportion is the opposite of direct, okay? Inverse means opposite in maths. So if you think about what's going on with direct proportion, it is the two things growing together at the same time. So inverse and opposites happening. One's growing as the other one's getting smaller. Now, if you think about our equation, for direct proportion, we had, and if I use the same letters we've got here, we would have A equals K times B. That was for direct proportion. If I'm going to do inverse proportion, if I've got one thing growing as another thing's getting smaller, obviously can't have the same equation. The inverse or opposite of times, which let's face it, is what is going on here, is divide. And that's exactly what is going to happen. That's the change for inverse proportion. So my equation for inverse is A equals K over B. So my times is changed to a divide, and now I'm working inversely. So one thing that I do see people not struggle with, but just get wrong every now and again, is they get their K and B the wrong way round, or K and X, or whatever you're working with, yeah? And they put K as the denominator. It's going to go wrong if you do that. So this is, for me, the best way to remember what order it is. Direct proportion, you write the K first, and then you write the variable. You write the K first, and then you write your variable. So if you just make sure, once you've done equals, you write K next, and then you squash it if it's direct, you stick it over, under, if it's inverse. And that's it. That's the only difference. Then everything else pretty much works in the same way. So let's take a look at this question. So we've pretty much done the first bit. So A is equal to K over B. A is 5 when B is 2. Rearrange to get K on its own, and you work out that K is equal to 10. I can now rewrite the equation. A is equal to 10 over B. The question is asking me to work out B when A is 12. So I'm going to replace the A with 12. I have got 10 on the top. I have got B on the bottom. Now, if I want to know what B equals, I know I've got to get it on its own. I can't move the 10. We've seen this before. I'm going to have to move the B whether I like it or not. So that divide by B comes up and it lands as B times 12. So I've got B, and I'm just going to show it rather than squash it because I'm going to move it in a minute anyway. So then that times by 12 will move, and it will land as divide by 12. So really what's happened is they've just switched places, haven't they? So B is equal to 10 divided by 12. You could cancel that down if you wanted to, which is 5 over 6. You could show the decimal if you wanted to. If you're asked to work it out and you've got a fraction answer, just write the fraction answer on the page. It's the right answer. So it's just written in a fraction form rather than a decimal form. So don't be frightened of fractions. So it's not massively different, is it? You've just got a slightly different equation. How does this work with the grid? If you're using boxes and labels is all about direct proportion. It is always about direct proportion. So technically it doesn't work here. You can adapt it, and I'm happy to show you the adaptation, but it would be something that you'd have to really remember for yourself, because the whole trapped number thing isn't going to work here because it's not direct. So let's clean this up and show you how it would work. So I've got my fact going in. I've got A and B. I've got 5 and 2. Okay. I'm being told that A is 12. Now, what I'm needing to do here is work out, what do I multiply 5 by to make 12? 5 times something is equal to 12. So actually, if I do 12 divided by 5, I will get that answer. So I, on this side, am timesing by 2.4. Now remember, I'm doing the inverse. So I'm going to divide by 2.4. And when you do that, you will get that same answer, okay, of 10 over 12, although you'll get the cancelled version. Doing it in the calculator makes sense. This is absolutely calculator work. So you really don't need to be trying to do everything by hand. That is how you could adapt. So no trap numbers, don't even go there. It will just work it out directly proportional because that's what it's designed to do. So you've got to adapt it if you're going to do it that way. Okay, obviously I'd like you to be writing out the equations, but I'm just trying to give some backup methods, all right, because it's nice to have a backup. Okay, so there is your have a go question. So okay, if you hadn't pressed pause and you're still working on it, pause and play when you're ready. All right, so this one is trickier. There's no mention of the word inverse. So we've really got to think about the context. We've got this fact that 4 workers will take 10 hours. So if I had 6 people on the job, and this is where I really do need to give context, think about the reality of this question. If it's going to take 4 people 10 hours, if I've put 6 people in, it's going to take less time. Okay, so I know it will be less. I don't know what the number is yet, but I know it will be less. So you've got this going up and you've got this going down. And you can see that that is an inverse proportion question. So you can either set up, there's nothing there asking you for an equation. So you could, if you wanted to, just go straight into your boxes and labels. I've got my workers, my hours. I love the labels. It stops you from putting things in the wrong boxes. I got my fact. I've got that. To go from there to there, I'm going to have to times. So I'm going to have to work out what I actually multiply by. Okay. So you do the opposite. You do 6 divided by 4. And then that tells you what to multiply by, which is 1.5. So you do the inverse, the opposite. You're going to divide by 1.5, okay? And then that gives you that. I've just done that in the calculator. I'm just checking that I didn't hit a key wrong because it doesn't look quite right. There we go. That's more like it. So that is going to give you 20 over 3. Or you can change and show that as a decimal. But remember, you should be comfortable working in fractions and allowing things to stay in that form. But decimal would be fine as well. That would be a recurring decimal, which is kind of why the fraction's better, because we don't have to round it. So you do need to watch out for this, because our inverse proportion, especially actually on foundation, they don't tend to use the word. They tend to do things like this, or the machine question's really common. So I've included that so that we're aware of it as well in our maths. And that, I mean, we could do loads of examples. I just don't think it's necessary. It really is the same. It's just a different equation with the same approach. And if you're using the box, just remember, if you times one side, you divide the other. They're the only changes. So the best way to learn this is to just get stuck in and practice, practice, practice. So I'll scroll through if you're working from the screen, and I'll do the answers. And then I will see you for our next session. So well done. That's a lot. That's a whole topic in one video. And I'll see you next session.